Hey guys, so I was making my key, decided to just video it so that I could explain the proofs to you guys as I'm doing them. I'm going to pause it and write some and then I'll talk about it. So you should be using this to check your answers. Okay, so when you see perpendicular in the given every time, that is going to be those two right angle steps. So that should be easy points no matter what. So there those are. Perpendicular means they form right angles. So here you have the reflexive property, which is marked in green there. And then this step, step 5, could be done in 2 steps really, or just one like I did, where I'm saying, hey, since it's perpendicular, it's also going to bisect it. That's a theorem from, I think, 1, possibly 2, of this unit. And then the segment bisectors make our 2 congruent segments. So now we have congruent triangles. Let's see if you can finish it. Here's that proof finish, side angle side, CPCTC. Hopefully that one went well. There's an alternative way to do this one. In order to prove these angles congruent up here, you could have said that these arcs were congruent eventually, because diameters and chords, they do not only, when it bisects the chords, it does make these arcs congruent, arc CB and arc BD. And then notice that those 2 angles are both inscribed angles in those congruent arcs. They would also be congruent. So it's kind of a shorter way, shortcut, but this is the more using our theorems that we've done way that probably makes more sense to people. Okay. Okay, so far I've just highlighted in red and green the 2 triangles that we want to be similar here. So we're obviously looking for angle, right? So the one angle comes very easily because they share it here. I'm going to call it angle 1. Remember, you want to stay away from calling it angle n because there's multiple angles at n. So there's the one angle. The other one is that they both have a right angle. So this is a right angle in this triangle. But that's a different reason than why this is a right angle. So I'm going to actually do those separately, which was done in your notes. So angle 1 is a right angle. Why? Because, whoops, I didn't just use angle 1 twice. So we're going to close angle 2. Numbering them. There we are. Okay, and it's because it's an inscribed angle that's intercepted by a semicircle, so that has to be a right angle. The other one is going to be here in the red triangle. So angle 3 is also a right angle. Why? Because a tangent and radius are perpendicular, which forms right angles. So again, that could be 2 steps. I'm just blending it into one. See if we can finish it from here. And there's the end of that proof. All right angles are congruent and angle. All right, the key is here is to use transformations in order to explain this. So you want to use as much detail as possible. I'm going to write my explanation and then talk through it with you guys. Okay, here's my explanation. So I'm going to translate circle A first of all so the centers map onto each other. And I'm telling you exactly until this point maps to this point. And then I'm dilating the circle. Notice I gave the center of dilation. And the other thing that I gave is the scale factor. And that's the same thing as 0.35 is the scale factor because I'm going to shrink circle A. You obviously could have translated B and then done the scale factor the other way too, made it grow instead of shrink. So you need to make sure you include those 2 pieces of information. And so they're similar to each other since they can be mapped onto each other with the translation and dilation. All right, this step 2 here is from that's a day 1 theorem that's coming from these same external point. Those tangents have to be congruent. So there's 1. Here's this proof finished. So we have reflexive, we have the radii being congruent. I did side, 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 and CPCTC. Alternatively, you could have used the right angles here and done side angle side. You could have done hypotenuse leg. So there were other options there. So could have been side angle side, could have been hypotenuse leg. I just went with side side side. I felt like that was easiest. So there's my explanations and my key. Hope it helped.